So it turns out there was a fifth example that I did not see when I was preparing stuff for class. So you should do this one too. Example 5 here is talking about quadratic regression. So what that means is creating an equation that is as close to given data points as you can. So it might not be exact, although this one will actually work out exactly. What we should do is watch the video in the example first, and then I'll help you work out the extra question here. So pause my video, watch the video online, and then we'll come over and do the other question together. All right, so for this one, it says a fan threw a souvenir football into the air from the top of the bleachers toward the bottom of the bleachers. So that's why his or her height is 10 to start, because they're up in the bleachers, and then time is 0 because that's when it starts. And then as time goes, the ball goes up and then it goes down. Then the question is, how does how long does it take the ball to hit the ground after it was thrown? So what we're going to do is come up with what the equation is based on having a table of information. And you're going to use your graphing calculator to do that. So let me show you how that's done. The first thing you do with and this is something you can only do with a graphing calculator, you can't do it with scientific. So hopefully you have one. Again, you should have access to an emulator on your Chromebook. But if you get a table of information, you're going to input that table into where we say stat. So stat, and then the first thing is edit. We're going to edit the table of information. And then we're going to input this table in here. So all the x values, which in this case are the times that the ball is traveling, go into L1. All of the heights of the ball, so all the y values are going to go into L2. All right, so if you need to pause, you can pause while we move on to the next step, while you're entering those numbers in. But once you have all the numbers in, you're going to quit back to the main screen. You're going to then hit Stat, Calc, and then you get a bunch of things that come up. What we're interested in is the quad reg, which is just short for quadratic regression. And again, that is terminology that means it's going to give you a quadratic equation that fits the data in the table. So something that certainly I wouldn't be doing by hand in any way. This is giving you might get the screen, you might not, but essentially this is just saying, yeah, I put the x values in L1, I put the y values in L2. You can adjust that there, but I'm not adjusting anything because I have it set up the way I want it. I'm going to scroll down, hit enter on calculate, and that's your equation. So that's the standard formula we've been talking about in this lesson. Negative 16 goes in for A, 12 goes in for B, 10 goes in for C. So the equation is negative 16x squared plus 12x plus 10. The question is, how long does it take the football to reach the ground after it was thrown? So essentially what it's asking is, what's the x value when y is 0? Because when the ball's on the ground, the height of the ball from the ground is 0 because it's on the ground. So there are plenty of ways that you can solve a quadratic equation. We have not discussed that in our class yet, so maybe you did last year, or maybe you did in Algebra 1. And that's cool if you remember how to do that algebraically. We don't have that yet, so we're going to use the calculator and the graph. We'll talk about how to do this as we get further into the chapter, how to do it by hand at least. But for right now, we're not there yet. So we're just going to type in the equation. We're going to graph the function. So I hit the y equals. I got negative 16x squared plus 12x plus 10. And then I'm going to graph. So that's what the curve looks like. The only part of the curve that actually is relevant to us is what's in the first quadrant. Because over here, the time is negative, so that makes no sense. Down here, the height of the ball is negative, which makes the ball, when it hits the ground, doesn't like start burrowing into the ground or anything. It just hits the ground. So the only part of this graph that is relevant is the first quadrant. the part that is our answer is the x-intercept. Like, where does the ball, like, what is the x value when the y value is 0? We can get the calculator to tell us specifically what that is by giving us the information for a 0. So I'm going to hit enter on 0. By the way, I hit second calc, all those things came up. And then I'm going to have it tell us the 0 that's image. So the left bound means I'm going to move the cursor to the left of where it's crossing. This is a little confusing because it looks like I'm above. I am above, but if the curve is coming in from the left, up here is to the left of where that 0 is. I hit enter. Bear with me. I hit enter too many times there. All right, this keeps messing up. All right, so left bound is on the left. I hit enter there. Now I'm going to move the cursor to the right of where the 0 is. I hit enter on that. Then I hit enter again, and it's telling me very specifically that the x value is 1.25. Means the ball is on the ground after 1 1/4 seconds. So that would be your answer there. All right, let me know if you have any other questions.